Welcome, everybody. We're going to pick up where we left off in Module 7. We're starting on slide 72 or 73, depending on how you're counting here. And we are going to talk about this other important, class-related concept called interfaces. And we're going to begin kind of in a weird place with that because we're going to really kind of ask a question about doing something with code before we learn how to do the interface component of it. But let's just say, for example, if we were working, let's say we created a list of strings that contains the name of instructors here at WCTC. And so some of you may have had classes with these people here. And, if we wanted to sort that list of names, we have this like tool that's built right into the list, which is called sort, right? And so and what you guys will recognize now with this syntax, right, the dot syntax and the parentheses, that indicates it's a method that's built into a list class, let's just say, right? So somewhere there's this thing, where it says class list, and then you have a method inside there that sorts, and it has some sort of an algorithm that looks at your contents and then decides, in the name of it, or at least with strings, that we're going to sort this alphabetically. So if I ran the sort method on this list of instructors that have been added to the list structure, it should return these results. And notice how it's alphabetizing. It just does the traditional alphabetization technique, which is you look at the first letter, does B come before M, does M come before S, right? And then if the first letters are the same, then it looks at the second letter and keeps going that way until it figures out which ones are in the right order. We're not sorting here by last name. These names are one long string with a space in the middle. So it's not looking at last name, it's looking at the whole string. Right, so Brittany goes first, Matt goes second, Stacy goes third. But that's just a method that's built in, and we can invoke it very simply because that method travels with, this construct of list, right? And this is one of the grand takeaways of working with objects and classes is when we create those class files and we add methods to it, the methods can perform work that once it's written, we don't have to rewrite that code. So I don't have to go in and write a sort algorithm. It's not that it's not possible to do, right? Now, if you do go on and formally study computer science, by the way, you will take classes, a very typical in a computer science bachelor's program is a course called data structures, where you do learn how to write sort algorithms and not just one, right? You'll discover that there's like, certain types of sorts. There's like bubble sorts and binary sorts and all these like different, like really bizarre ways of organizing data that IT geeks like us spent years and years and years trying to figure out how do we really sort stuff and what's the mechanism for doing so. And then there's code that goes with that. And what you learn, if you study data structures and sorting is that there's dozens of different sort algorithms. Some are better than others. Some are lightning fast, some are super slow, some are accurate, some are not accurate. So very, very interesting field of study. I'm sure you guys are thrilled just by me talking about it, but it is kind of one of those really dry concepts. It's kind of like, learning about math. It's not a really exciting subject. So like sort's just one of these methods that's written, you just utilize it. Right, you're probably not going to go in there and alter the code or write your own version, right? Like with toString, we're writing our own version. With sort, you could write your own version too, but why on earth would you, right? If it's built into the class structure, you just utilize it. You just assume it's right and it's good. Okay, so that's just built in. All right, so if you have, let's say, relatively simple data types, it's not a big deal to do a sort, right? So for example, if we created a list and the list is not a simple data type like a string or a number, and it's a complex object that has multiple data fields built in, and in this case, you're using a customer, right? So it looks like a customer has at the very least, a first name, a last name, and I'm guessing an ID number, right? We can speculate whatever that number is. Um, and then because it's a complex object, if I was to run sort on this complex object, what the heck is it sorting? Well, here's the answer. We just don't know, right? I mean, it's going to sort based on something, but really we're going to have to designate what it is we're sorting on. But if you think about it, the possibilities are that we could sort on any one of those things. So, hey, why don't you sort by last name? Why don't you sort by ID number? Why don't you sort by first name? And if you want like a comparison, a good comparison is if you're like a spreadsheet person, like if you have columns in a spreadsheet, you can run sort algorithms like right inside of Excel or Google Spreadsheets or Mac numbers or whatever. You just like have it sort ascending or descending on a column and all the data kind of shifts with it. Well, that capability is here too, but you do have to designate which of the fields you would sort on. If you don't, if you just try to run sort on the customer object, which has multiple properties or data fields, if you will, you're going to get a compiler error because, well, it's like, I don't know what we're sorting here. You know, it's like your, let's say, your significant other, your spouse, your wife, your husband says, hey, I want you to sort the socks in your drawer. How do you sort your socks? You know, winter socks, summer socks, shorty socks, career socks, by colors. You know, I mean, it all depends, right? You know, which property do you want to sort on is really what it kind of comes down to. So notice like the compiler error on this, you know, it really is very bad, right? It says failed to compare two elements in the array. Well, yeah, because basically it's saying I don't know which ones to compare. And there's this other thing here that'll say at least one object must implement I comparable. So in other words, what it's telling us is that we're missing something in our class structure to allow the sort to happen. So in other words, with a string or a list or whatever, that's got the sort method built in because when you're sorting strings and numbers, well, that's a piece of cake, right? That's kind of a normal thing. But when you're sorting a complex object, could for, you know, for all sakes and purposes contain other objects, what are you sorting on? So this is why the compiler just freaks out. It doesn't know what to do, right? So once again, in order to make it happen, you need to designate what you're sorting on. All right, so we have this thing that we add basically called an interface, right? And we use this interface type called iComparable. And let's read what an interface is first. So if you guys remember, we had abstract classes, right? And those had special kinds of features. And now we have what we call an interface. And an interface is very similar to an abstract class. They don't contain anything except abstract methods. So I want you to think about what that means. They will not contain data properties or fields. They will just contain methods, which are basically functions that that you can just use, right? So, and it says here you can't make an instance of an interface because you know the contents are basically abstract. You're like, oh, it's really kind of a collection of functions that you're just pulling from and using, right? So that's really what it is. So it's like, hey, look at all these cool functions here. Why don't you use them? One that, like, for example, we would create in order to be able to sort a complex object would be one that we call I comparable. And this is kind of, it's not a hack, but it's kind of like an override of sorts, if you want to think of it that way. But basically, we have to build some sort of a compare to method so we can compare one object type to another so that we can start to do the comparison. So when you look at this, you know, it failed to compare because it doesn't have a compare to built into it. So when we do this I comparable, for example, it's missing that piece. So if we want C#, as it says here, to sort holistic customers, we require that that object, the customer object, which comes from the class, have a method built into it called compare to, named exactly like that, capital C, capital T, that allows us to compare the one object to the other in some fashion. Notice there is no like complicated code definition here, right? We create the interface, we give it a name, then we say compare to, right? So now the interesting aspect of this is, and it says here, this is our guarantee that the customer will have a compare to method, and it won't compile unless we do, right? So until we add this piece, we would actually kind of declare it like this. So let's say a customer, so like building on the examples that we've been doing in this chapter, right? There's a person, persons can be of types. And so when we build a class of customer, it really inherits from the person class, whatever capabilities come with that. So maybe that's first name, last name, you know, an age or a birth date, or, you know, you think of what makes up a person. But what makes a customer different from a person, right? Well, a customer would be somebody that comes in to patronize your business somehow, right? They want to give you money, you know, if you want to think of it like that. And then notice the syntax here. So this, the first part of it on the first line, typical, right? This shows that the customer class is inheriting all the capabilities of the person class, or in other words, customer is a child of the parent person, or person is the superclass and customer is a subclass. Remember all that stuff, right? I keep like repeating it, so hopefully it sticks, you know. And I understand if it doesn't stick, I know this stuff's kind of heavy. But we also have to have this declaration in here where we do this I comparable thing in order to be able to basically make it comparable based upon customer objects. So in other words, what this is saying is it's pulling in not only the superclass of person, but it's also pulling in the interface called iComparable, which can compare customer objects to customer objects. Now, the rest of the code inside the class, that's what the dot 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 is. Whenever you see that in programming books or, you know, examples, dot 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 means there's a bunch of code here. It doesn't really matter what it is. Doesn't mean there's no code in there, but there's some code in there. Now, a customer, you know, might have a customer number. They might inherit the name, first name, last name from person. But, you know, what else would a customer do? They would have purchases, for example. So like if you went to like, you know, a store, and I'll use like Costco as an example, right? Like if you go to Costco, one of the reasons I like shopping there is like you walk through the door, you show them your receipt, and I take the receipt and I throw it away. And my wife's like, "What are you doing?" And I'm like, "Well, it's all attached to our account, right? So they know what I purchased because they scan my membership card first. So if I don't have a receipt, I can just walk in. They can look me up if I don't have my membership card, and they can just attribute the transaction to my account, find it, right? So it's kind of convenient, you know. So that we can have that ideation that that's going on. And then if they were to look up, for example, hey, when did you buy this carton of eggs, for example? They could look back through my history, and they could maybe even sort all the things that I purchased by date, or maybe they can sort all the things I purchased by product type. Like I buy eggs there all the time. So when was the last time you bought eggs? Oh, there you go. Okay. And they can find that. So we could sort on the last time I purchased eggs, for example, right? And these are the kind of mechanisms that we're really referring to here that enables those kind of systems to take place. So if you're wondering, you know, why do we do this? That's the why. It enables those types of capabilities. And I want you to think about that really carefully, because we kind of take that for granted, right? Now, if you walk into some stores and you pay cash and then you throw your receipt away, try returning the object, right? They have no way to identify you as the customer, right? Very interesting kind of thought here. All right, so how do I sort? Well, it says your friend wants you to help sorting his toy cars. You pick up two cars. What order do they go in? Well, it depends. What are we sorting by? So this goes back to this concept. Are we sorting by the model? Are we sorting by the color or something else? You know, it could be a lot of different things, right? So any of you that maybe collect like Matchbox cars, right? So and I'm one of those people that grew up in the era where that was like a really hot toy, right? And then now I learned that some of those old Matchbox cars that I totally got rid of, we probably gave to a thrift shop or something many years ago, the ones with the little red marks on the tires, those are worth a lot of money because they're pretty rare. And I'm like, all of mine were those, if I only would have kept them, right? That kind of thing. Um, but what it comes down to is your friend really has to tell you, well, I'm going to sort them by color, or I'm going to sort them by, which ones are Fords and which ones are Dodges, that kind of thing. So by model name potentially. So there's got to be a designation for it. So if we were to add then a compare to function, we might do something like this. So we would allow it to feed in, like, so we'll call it compared to, we'll allow an object to be fed in. When we say other here, the implication is that the compare to function is embedded into the class definition for customer. So if I'm comparing to a different customer object after it's been created. So I have the one it's traveling with, and then I'm like, all right, well, I want to compare to the other one and see what I'm going to sort. So we feed in the whole object. So that's a very typical nomenclature, if you will. Then what will happen here in the code is we'll choose the data field from the object that we want to compare against. So we're taking the last name of the current object itself, comparing to the other object's last name data field, apples with apples, right? That's how we do it. And I think that's kind of interesting too when you do this kind of coding, and this is modern coding, by the way, where what we're doing in the code starts to almost look like an English sentence, because, hey, what are we doing? We're doing a compare to, we're going to return the last name. We're going to compare the last name of this object. We're going to compare it to the other one's last name. So it's almost like an English sentence. And lucky you guys that the syntax is like that. And and more importantly, it says it satisfies the contract made by iComparable. So in other words, the compiler would not fail in this circumstance and would process. And if you think about this, we could have, so there's a standard compare to, and it would make sense to me, like if I was a business person, if I was to sort of list of customers, last name is probably the order I would choose. Most likely. Is that the only way that you could sort? No. Let's think one more thing about sorting, which is kind of fascinating. When you would, let's say you go to the library, and I don't know how many people even still do that. I know the people in my family still go to the library pretty regularly to get books and music and whatever. But if you guys recall the old days of the library, and it wasn't that long ago, you would walk into a library and they would have what we'd call the card catalog, right? And you could go look up a book by subject, author, or title. And really what they were doing is they were taking all the books in their collection, creating an index card for them, one sorted by the author's last name, another one sorted by the subject material. So maybe it's history, maybe it's philosophy, maybe it's car repair, right? And another one sorted just by the name of the title. Same collection, three different sorts, three different orders. Kind of an interesting thought, right? And think about when we think about a card catalog, it's really kind of an index is another way to think about it, right? So if you ever read a book, textbooks are really good for this, by the way. You can usually go to the back of it, look at the index, and if you're looking for a certain topic, you can find that topic and then go to the page number. Pretty helpful, right? Why this is one of the reasons why textbooks are so expensive, by the way, is they have stuff like that built into them. All right, so now really what we're going to try to do here is do a little hack of the dog class so we could list or sort a list of dog objects by age. So now we have to do a little revisiting of the code here to kind of refresh where we were at. So I'm going to begin by opening up what we were working on last time. So I have my module 7 try it outs here. So if you guys remember all this code we wrote last time, we wrote a lot of code, right? We wrote a lot of methods, wrote a lot of classes. We were steering it all from the main method. And this is just kind of like the revisit of all that material. Now, because we're going to be working with the dog class, and I'm trying to find my code on the other screen here, we are going to have to put in an icomparable. And you know what? Truth be told, it doesn't have to be the dog, right? It could be the cow. Or remember, like we did like a cow 1 and a cow 2. You remember all that, right? So we could, for example, just do this on the cow class. Okay, so I think that's what I'm going to do because that's what I did in my example on the other screen. Even though the try it out says to do it with the dog, whatever, doesn't matter the animal, but the concept is really what's important. So let's revisit all that information. So we had, this is the code that runs it, or the function that runs that. But down here somewhere, we did have first the pet class. So I think it's important to kind of revisit all this stuff so we just remember what we had. So we had a super class called pet, right? And remember, like when we first built this, we're like, well, you know what? It would be silly to have a pet class where, you know, any pet can say hello, because that's just not how it works, right? So we said, all right, we're going to abandon the original pet class. And so we're going to build pet 2, and it's an abstract class, right? So I can't directly instantiate an object from it, but I can use it to build subclasses or sub objects or child objects, if you will, right? That had a name and an age. It had a constructor that was a default constructor that was blank, and then a constructor that allowed for 2 inputs, right? And then we had some abstract methods. So we created an abstract method called string or speak, right? So in other words, no code here, but that means that the subclass must include a speak method that tells you what sound the animal makes. We also wrote an override of toString that returns the name, the age, and what the animal says. You guys recall all that, right? Then we went ahead and we created the cow class. And the cow class, remember the syntax here, this indicates inheritance. So it inherits from the superclass pet2, the one that we were just looking at. The only data field that we're adding here is whether or not it has spots with a getter and a setter. It's a Boolean, true or false. It has a constructor that allows for 1 parameter to be passed, which is whether it has spots or not, or a constructor that has name, age, and true or false on the spots. And the name and the age actually feed from the base class or the super class, right? So when we're saying name and age, it's actually going up here and populating these, right? So that's kind of the structure of that. And that's the syntax for it, right? And that's because we're doing inheritance, but kind of cool that you can instantiate from a superclass and then populate the stuff that comes from a superclass. We have our overrided speak method, cow say moo, and then we have an overrided toString method as well, right? And if you guys recall, it has spots, does not have spots. We even had a little true false thing in there, and it did kind of whatever. But if I wanted to kind of build up this example, and let's say I wanted to add the compare to function with the icomparable, here's how we would proceed. Instead of you know, using this one and just changing it. I'm not going to do that. I'm going to leave this one intact, right? But what I'm going to do is I'm going to borrow really heavily from it to do the iComparable and the compare to. So let's do that. Let's create a cow2 class. All right, so that's where we're starting. So here's the definition. We're going to do public class. We're going to call it cow2 that will inherit from pet2. Okay. Then we're going to throw in the iComparable, so comma, and then capital I, capital C, iComparable. And then notice that it gives us the angle brackets there, and that's what I want. I want that second option. And then inside those angle brackets, and it didn't populate it, I'm not sure why, we are going to do this, which is going to show basically the C# engine that we will have a compare to function inside of this class definition, right? So that will allow us to sort that object type. Now I'm sticking on the error message here so you can see that it is looking for a comparison method, right? And you know, the other thing that it's also looking for inside those angle brackets is the type of object to compare. What kind of objects are we comparing? Cow2s. That's what we're comparing, that object type. All right. Now let's go ahead and throw in our curly brackets here. That will stay underlined red, by the way, until we throw the compare to function in. Now, in order to accelerate the development here a little bit, I am still going to use some of the stuff I used before. So for example, has spots, the Boolean, right? We're going to keep that in there. We're also going to have a blank constructor. So there's that. All right. If you guys are typing and you're like trying to keep up and you're not catching up, all right, here's my kindness for the day in the chat. Right, so you can just copy paste that and you're right with me, right? Now, we also probably want to think about, like, when we were up here and we were doing, all these constructors, could we do the same thing? Yeah, you could. So yeah, you could copy from this code too. So I'm just going to borrow this and drop it in here so we can have an overloaded constructor, but we do need to name the cow2. Could I borrow like whatever the default was up here? Sure, I could do that too. So we could borrow this piece. I could have copy pasted it all. But one of the problems that happens when you copy paste is sometimes you forget to fix things. And if you do it incrementally, you're less likely to make a mistake because you see the red underline rather than pasting a big block of code. Some of it goes off screen and you don't see it. That's kind of my way of thinking. You can do it any way you wish, of course. We're still going to have the overrided speak method. And now why am I adding this? Because, if we're going to like do output on this, it's got to be there, basically, is the answer. All right, so we have the speak method. We can also include the toString method, and I'm just trying to see if did I change it in any way. Not really. Here's the one I'm using right now. If you guys want to copy it, you're welcome to. Oh, no, that's still the, never mind. Let me do that one more time. Second time's the charm. There we go. That's what I'm going to paste in here. So that's the toString. Now let's get to that compare to method. So I'm going to start coding this by hand. I'm going to say public, and we're going to say int compare to, and then what are we comparing it to? Another cow2 object, and the default kind of naming convention is other, because the one that we're inside is this one. The one outside of here is that other one, whichever one it is. Doesn't matter which one it is. So then we'll go ahead and put in our curly brackets. And then all we have to do to return this is do the same syntax that we saw on the slide. So we're just going to say return, and we're going to say, well, if it asks us to compare by age, right? So we designate the data field we're using. So we're going to use age, compare to the other's age. And you can see the syntax is so common that Visual Studio is just filling it in for us. All right, pretty interesting. And one thing that I guess we didn't talk about is why is it returning an integer? That's an interesting thought. Like if you're comparing one to the other to see which one comes first or next, what could be the possible return values? One thing you could do is you could write code to check to see what it is. But this is kind of an interesting thought. Why is it an integer? Why wouldn't it be a Boolean or a string or something else? Because the sorting ultimately, I want you to kind of recall this. When we sort letters, what's really happening is we're not sorting the letters the way we learned them as kids, right? A, B, C, D, E, F, G. We're converting those letters to numbers and comparing the numbers. So the integers, the numbers are the basis of comparison ultimately. So that's the why. All right. So now we have, this going on. And you know what? We're going to have to compare multiple cows, if you will, right? And we could build additional objects. So just for example, we can take this inheritance thing like way down the rabbit hole, right? So for example, I could, do this. I could create a public class and call it calf, right? Because a calf is a kind of cow. And in this case, we'll make it a cow of type 2, right? And so we could, for example, have a calf that inherits from cow 2, which inherits from pet, et cetera, et cetera, et cetera. You guys feel where I'm going with this, right? And I'm not really writing any more code here, but I just want to show you that that's a possibility. But it's a conceptual leap once again, right? Not that a cow is necessarily a pet, although, like I said, I've known people that have actually had cows as pets. And we have a cow too, and a calf is a type of cow. So, you see the logic there, right? So now what we have to do is we are going to have to run some code around this, because nothing's going to happen with this code. This is not executable, right? This is just a class definition. So let's go up here to the top, and we're going to create, we're going to have to create a new function, right, to run this. And what I've been doing mostly is like when I create functions and I'm kind of deactivating the previous ones. Well, I do have a couple of cow objects here, and I have a cow 2 object. So this is my pet 2 demo. I think I'm going to call it something else. And really, when it kind of comes down to it, what we're really doing is we're creating objects that are a little bit more complex than what we're thinking about now. And what we start naming things really becomes relevant to the conception. We do want to run some sort of a demonstration here. And all right, I'm trying to find my comparison code that I wrote here. I have so many lines of code on this file, like I said before. Okay, so we're basically gonna play with a few different things here. So if you guys can just hang with me in terms of how I'm kind of structuring this together. The last time we did this, we ran pet 2 demo, which was here. I'm just kind of looking at how we put that together. So we have cow 1 and cow 2 there, and then we drove it up here. So let's deactivate that one. We might borrow some code from it. We'll kind of see, right? Because I don't really want to retype too much. And what are we going to call this one? well, we can call it like interface demo, or we could call it, yeah, let's call it interface demo, I guess. Um, let's do that. That makes sense to me. Now, this is kind of weird because I'm typing in the name of the function here, and it says it doesn't exist in the current context. Well, of course, because we haven't created it. But it does say show potential fixes. And I don't know if you guys have tried this approach before, but I can actually let it auto create the function for me. Like this is kind of weird. So this is backwards coding. So I do this in Java all the time, by the way. So I haven't created the function yet, but I named it here and I want to launch it, but I don't have it. And it shows me one of the potential fixes is, hey, I can generate it for you. Like, you know what? Let's do that. Let's have it automatically create. Right. Why? Because, basically it saves me time. That's the why. All right. Now, this is set to private, and I haven't been doing that. I'm just going to remove the private designation. It's named correctly. It also has this exception handler built in that we're just going to delete. We don't really need that. All right. So now let's think about what we need to do. We need to create at least 2 cows of cow 2 type based on pet 2. And then we need to be able to compare their ages. So I could borrow my code from here, the pet demo, where I have a cow and a cow 2, but these are the, okay, these are the old school cows, right? They're not the cow 2s. So, but I am going to change the object type once I do the copy paste. So follow with me here on this. I'm going to paste this in. And instead of building original cow objects, we're going to build cow 2 objects. So I want to make sure that I go through in these spots here and add 2s. So tells you the object type, right? The constructor. And you see how I'm hovering here. And what I'm showing you through the hover, by the way, is where it's being pulled in from. Why is this one failing? Second one's fine, right? I'm sending in Betsy, 3, and false. And notice as I hover over cow 2, it says, oh, you have a constructor that needs a name, age, has spots, and 1 overload. What is happening with the first one that's failing? Why is that failing? Anybody see it? Okay. The answer really lies in the cow 2 definition below. So let's go down there and take a look at cow 2. We'll collapse this code. We'll look at not pet 2, but okay, so that's the old cow. I'm collapsing that one too. Here's cow 2. We have has spots, gets that. Okay, that's fine. We have a constructor that's blank. Does anybody see the problem? I'm just like waiting for somebody to answer here.
You need the data type and the has spots variable Boolean.
Yeah, so we need to throw in up here, Alex. You're right, Boolean, right? And yeah, it's already like figuring out what it should say there. Thanks, Visual Studio, for messing me up there. But has spots is what we want to add. So it's expecting to receive it, but our default constructor or our 1 parameter constructor didn't even feature it. So that's why it failed. I could have had it automatically assume spots and not pass anything in. So I could have just set it to true, that kind of thing. But it was expecting something to come in. So that's why we had to put it in. All right, let's go back up here. So now that error is now resolved, correct? We have now created 2 cow 2 objects. And you know what? I'm not sure I like cow 2. Let's call it cow 1, cow 2. And then if I'm doing that, then I better update all this stuff. And this is kind of a little bit of a lesson here in terms of like, you're making the one change, you got to be consistent and follow through. All right, we're using the same info that we did for the other one. Now, how do I prove after I've done all this? Can I run this code and see if it worked? How about that? Okay, right. Let's see if the objects are created correctly and see if it's grabbing the information and at least putting it back up on the screen. And it says there's build errors. Okay, so no, we don't want to run the last successful build. We want to go to where the error is. And where's the error in my code? Well, I would go to that red mark to find the error, right? So we're just going to scroll down here. Oh, calf. All right, so that's the code I really didn't follow through on. I really didn't define it too well. All right, let's get rid of that for now. We can create a calf later. Let's not do that now. All right, let's go back up now and execute. So we're gonna drive the interface demo. Here's the code for it. Here's the run. All right. So basically the same thing we had last week. Woohoo, we spent all our time and we just recreated what we already did, right? No, we have added wrinkles to it. So now it's a matter of like, how do we do the comparison of the one object to the next? What's the return value? How do we do the compare to and have it execute? Okay, so this is where it gets a little weird because we're sorting and it doesn't matter which one we're sorting on. So for example, if I was just to do, let's say, a console write line, and I hope you guys are following with where I'm going here, and I'll use cow2 as my primary object here, but I don't want to call the speak method. That's just going to say move, right? What I want to call is compare to, and what are we comparing it? What are we comparing cow2 to? Cow1. Maybe I should have used 2 and 3 or 3 and 4 or something. But yeah, we're going to compare it to cow1. And then we're looking to see if it comes before. Does cow2, how does it compare to cow1? So let's run this and see how it outputs. And it'll be kind of telling in terms of the mechanism. All right, so I have a -1. So what the heck does that mean? Okay, so this is kind of an interesting thought here. Okay, so it's returning -1. So what if I took, let's stop that code from running. What if I took the cows and flipped them, right? So what if I took cow1 and compared it to cow2, like flip their order, right? Now let's run it and see what the output is. So I run this code. So the first, if you want to do it like this, right? The first compared to gave us a -1. The second compared to, when I switch their order, is giving me a +1, right? So both of those are integers, correct? One's negative, one's positive. So it must mean something. Well, we can actually decipher it without actually going into like the C# code method libraries to figure out what the return value should be, which is one approach to doing it. But cow2 is how old? 3. Cow1 is 5. So when I'm comparing the second one, cow1, which is 5, compared to cow2, which is 3, it's telling me 1. So that indicates what? That they're in order or not in order? They're sorted or not sorted? What is it telling me? Because let me ask you this, is it sorting? No, it's not sorting them. But we're getting a return value. So when we look at this, we can now say, if it returns a 1, that means the cow we're looking at, that's our current object, comes after the one that we're comparing it to. If it returns a -1, that one comes before in terms of a sort. Then all you have to do to actually sort them is what? You just write an algorithm that places any, if it returns a -1, that one comes what? First or second? Which one is it? Right. So you guys have to think about it again. But okay, so cow 2 is younger. So if we're sorting by age, do you sort biggest to smallest, or you sort smallest to biggest? Okay, now the answer to that truly is it depends. Right? Right. So if you were like at school and you guys are lining up to play like sports or something, and your gym teacher says, I want you to line up from tallest to shortest, right? Or shortest to tallest, it would be a different order, but the concept's the same. It's just a matter of which order you're going in. Remember, with integers, when you're using a sign on a number line, it just indicates direction. That's all positive and negatives really are. A negative number, at least on the number line, the way we learn it, goes to the left. A positive number goes to the right. So then it would be up to you as a coder to use that to set up the sort in the way that you wish. So the algorithm could be one way or the other. It just depends on how you're sorting, right? So you could have a sort ascending or sort descending. It's all in the code that you write, right? But once it's in numeric form, you're only comparing two things. That's why they use +1 or -1, and that's why the return type is an integer. Kind of an interesting thought. Now, let me just pose this question really quick: did everybody follow along with the code and get theirs to work okay? Right, you got all that going. All right. I think it would be really good. We've been going for a while already. I didn't realize like an hour and 10 minutes already. Let's take a break, and then we'll come back and we'll review a little bit of this, and then we'll switch over to working on the lab assignment. I think that what makes sense to me as well is I might start a new video, but I'll figure that out while we're on break. So I'll see you guys in about 5. So we took our break, and then I realized I forgot one part of this demonstration that's pretty important. We did write the modified cow2 class. We added the iComparable and the compare to method. We ran the code to actually compare the cows and see what the results were. So we had a little bit of insight to what the integer return value was. And that's helpful. But what about that whole sort thing that they were talking about? I forgot to do that demo. So what I'm going to do here is I'm going to take this example and kind of go back to the first example that we had on the slides, right? And don't worry, this is coming up in the chat. So remember this from the slides where we created a list of instructors, right? And then we added a few instructors, and it's probably only appropriate here to add myself. I'm not a full-timer like these guys, but whatever. I don't rank with them, whatever. But there I am. I'm on the list, right? And alphabetically, I would come last. Oh joy, right? The other thing, from the example, if you recall, is we did run the sort. So we can just say instructors dot sort as a method with a semicolon. And then if I want to prove that it got sorted, I can just simply do a very simple for each loop in the chat, by the way, if you're following along, and I'm just going to paste it in here. So there's the for each loop. So it goes through, we create the list of strings, drop the names in, we run the sort method, and then we just list it back out. So let's run that and just prove that it works. We'll ignore the cow stuff for now that goes with it. But there you go, Brittany, Matt, Stacy, and Takis, right? All on that list, correctly sorted. And that works, remember, because this list contains string objects. And when a list contains string objects or numbers, the sort is pretty simple. It converts the string to numbers, and then it does the sort numerically, alphabetically and we call that an ascending sort. So it starts with the lowest number and it ascends, right? And that happens automatically. Okay. I didn't have to write a sort method or anything like that to make that happen. Now, if we look at cows, conversely, and because I'm building off of a different example here, I'm going to paste these cow objects in, and then I'm going to rename them, by the way. So I'm going to name these cow 4 and cow 5. I skipped over 3. I think 3's was cut up into pieces and put in my freezer for future consumption or something, right? All right, I'm just being funny about it. All right, so if we have 2 more cow2 objects, we sent in all the constructor stuff, and you know what? Like, if we're sending in the constructor stuff, we may as well have the names match, right? So cow 4 and cow 5, and then we can create a list of cows. So, for example, we can create a list that contains objects of type cow2. And I'm just going to name it cows. And the constructor looks good to me. I'm just going to follow through and let it create. So it's going to new list of cow objects with all their inheritance, all their overridden methods and abstract classes and all that kind of stuff is all in there, right? It's a list that can hold that complexity. Then I want to add a couple cows to the list. So I can just say cows, when it was giving me the code, right? I should just press tab and let it auto-complete. So there's cow 4. And you know what? Let's do that again. And thank you, Visual Studio, for reading my mind and writing my code for me. Not quite AI, but it feels like it. Boy, if I had that tool when I was like learning how to code, man, you guys are so lucky. There was no engine doing that for me. Now, here comes the tricky part. Can I now run a sort method on this? This is really what the example is pushing us towards. We forgot all about it. And actually, I forgot, not you guys, right? So if I take cows and run sort on it like so, it's not screaming about, it's not underlining it red, right? So apparently this is going to work. When I call the sort method here, what is it really doing? It is looking at the cow2 class definition, looking for the comparative function in order to do the sort. And the -1 and the +1 means something for that method. So now, in order to test this, I'm just simply going to write this little loop for each loop that's going to read through that list of cow objects, and then it's going to output each cow, hopefully in order, right? Now I could, for example, also put in, if you're wondering, we're not going to sort at this point. We're going to add. I could put the other 2 cows in too, but maybe I'll just throw in cow 2, just for the sake of example, to show you that as long as they're of the same class structure, you can do this, right? Because they can go into this list because they're all cow2 objects, right? So now I can run the sort, and then I can see the output. Let's run it. Let's see, right? Our old code, of course, is in there, so the instructors are sorted. And then, is it sorting correctly? Okay, I didn't come up with really good names for the cows, right? Betsy is a better name than cow 5 and cow 4, but what am I actually sorting on? Yeah, we're sorting on age, not on name. So are the ages in order? 2, 3, 5? Yeah, they sure are. Right, so it doesn't matter what I call the cows. The sort is based on age. Right, and you can think of like a farm scenario, if you will. I don't know if like farmers sit there and name their herd like all individual names. And strangely enough, I actually have some friends that do that professionally, and one of them actually raises pigs, and he does name all the pigs and gets to know them before he slaughters them and eats them or sells them and makes sausage. But anyhow, right? The point is, that now that we wrote the compare to with the I comparable, so why that sort works on those objects is because back here we created that compare to using the I comparable, and this allows the sort algorithm to sort on the field that we choose, whether that field comes from the subclass or the parent class. And I think that's really, really powerful stuff, right? Very useful, by the way, for the lab that we're about to do. And I was looking forward at the lab, which made me realize I forgot to do this part. Now, I'm just going to kind of review this with you guys. And so up in the main method, we're using this to drive the code. Then we wrote this function that first we created a couple of cows. We ran the compare to see what kind of output it had. Right, so that generates integer output. Then we did what we did in the slides, which is build a list of instructors, which is just strings, right? Added them to the list, sorted it. Sort works with strings and numbers. And then we just outputted the list one at a time, one item at a time. And we saw that it did sort, right? And then we created a couple of cow2 objects in addition to the couple that we already had. We created a list of cow2 objects. We added the cows to that list. We then ran sort, which works because we added the I comparable and the compare to method. And then we outputted it to prove that it worked. It sorted on age. So that's really, really cool that you can do that. And it shows that when you create an object like this, if you want a default sort data property from that object, you can do it, right? And I don't know if age makes sense. Maybe to a farmer that makes sense because the older cows maybe are the ones that go to slaughter. You know, I don't know like what the pattern is for a farmer. If I was doing a customer list, I would probably order it on last name. If I was, you know, if I was maybe doing like scores in a class, I might score it from highest to lowest, inverse, right? Or maybe I would do it the other way around, right? There's no rule as to how you should do it. You are the one that's in control. All right. Now, what I'm going to do here is I am going to stop this video so that, you know, the lab video sits separately from this, but we are going to turn our attention to the lab now. So this video ends here.